Okay, welcome. For this chapter, we're going to be talking about statistics. So let's get started. First, we need a couple of definitions. A census is when an entire population can be examined. So the U.S. Government conducts a census every 10 years to determine the United States population. Surveys, written questionnaires, personal interviews, or telephone requests. For info, so for information when experience, preference, or opinions are sought. Okay, controlled experiment. This is a structured study containing usually two groups. One that tries a new medicine, or some sort of technique or method, I'm going to put down, and one that does not. Observational studies, similar to a controlled experiment. But the researcher does not apply treatments to subjects. They observed after this treatment has already started. Okay, population versus sample. Population is when the entire population is examined. Like the census. And a sample is when you're looking at a portion of the entire population. So if I wanted to look at the junior class, that's a sample of the entire population. If I said the entire junior class, that could be an actual population. It depends on the wording. Okay, suggest a method that might be used to collect data for each study. Tell whether your method uses a population or a sample. So customer satisfaction at a restaurant, I would think would be a survey of a sample. And you would collect data from, say, every 10th person leaving a restaurant or leaving the restaurant. Grades for students on a test, I would think would be a census on a population. It's an entire, group of students, so it would be recording all students' students' grades on a test. And then a student decides to do a statistical analysis of the rainfall in a certain area of the country over the course of a specified 30-day period, would be an observational study. Of rain for 30 days. And it would be a population. I don't know that we'd really apply a population or a sample because it's an observational study of rainfall. I think that one doesn't apply. In order that the sample reflects the properties of the whole group, the following conditions should be met. The sample must represent the group being studied. The sample must be large enough to be effective, and the selection should be random with no bias. So, a new medicine intended for use by adults is being tested on 5 men whose ages are the following. Does the sample provide a valid test? I would say no. The test is too small. Or it uses too small of a sample group. So I'm going to change that. Only men, that's a bias, and they're all under the age of 30. Actually, they're less than or equal to 30. So there's a couple of issues there. It's really not representative of the group being studied, which you would think would be maybe a larger group of people. They're only choosing men. It says a new medicine intended for use by adults. It doesn't say intended for use by men. And it's targeting men between 22 and 30. So what about the older men or the even younger than that? Which method of collecting data would most likely result in an unbiased random sample? Selecting students by their last digit of their school ID number to participate in a survey about cafeteria food. That looks pretty good because you're not being biased. You're just looking at their school ID to decide who to talk to. B, selecting every third teenager leaving a movie theater to answer a survey about entertainment. That would be a bias because they're at the movie theaters, so you should be maybe going to a different location than if you're talking about entertainment than a movie theater. C, placing a survey in a local newspaper to determine how many people voted in the presidential election. I think what happens there is you're, again, biased because you would assume people that read the paper would vote. That's been shown. So that would be another bias. D, surveying honors students taking a specific math course to determine the average amount of time students in a school spend doing homework. I would not necessarily think that that's a good group to sample either. So it is choice A. Okay, so next we're going to look at organization of data, histograms, and stem and leaf plots. Okay, so you have your frequency and cumulative frequency tables. Histograms, bars are next to each other, breaks are optional. Stem and leaf plots, Okay, so and that's listed there how to do those. So let's take some grades from last marking period. So I have just listed out some grades. Okay, so I put them in order, which makes it more useful. So if we put them into a frequency distribution table, oh, we're skipping. We're doing the number of siblings of students in our class. So for this one, I think I just made up some numbers. I should have asked this question during class, and I didn't gather the data. So F sub I, that's supposed to be an F. All right, that represents frequency. And X sub I is how many siblings. So it's possible you have no siblings, one sibling, two siblings, three siblings, 4, 5, 6. I suppose it's possible to have 7, but that's generally unlikely. So I'm going to stop at 6. So 0 siblings, we could say maybe there's 2 people with no siblings. A lot of people have 1 sibling, so I'm going to go with like 10 on that. A lot of people also have 2 siblings, so I'm going to go with like 8 on that. And then we'll say like 3, and let's go with 2 and 1, something like that. Okay, so that would be a frequency distribution table. Next, graph the histogram of the data collected from exercise 6. Use the following intervals and the frequency distribution table below. Oh, I never did put 6 into a stem and leaf, so let me do that real quick first. So to do the stem and leaf, you take and you take all the 50s and you would put 5. I think I'll do it over here. And you take all the 60s and you put a 6, and the 70s, 80s, and 90s. And then you draw a line, and then you list there was a 55, then it jumped to 65, 65. So you just write the tens digits, so I mean the ones digits, so 65, 65, 69. So the 9 from the ones digit and another 9, and then there's a 70, 77, 77, and then there's an 80, an 80, and an 80, and an 81, and an 81, and an 83, and an 85, and an 88, and an 89, and then there's a 90, 91, 93, 93, 94, and 95. So you can kind of then see a little bit that, this way looking that there's more 80s than 90s, but there's more 80s and 90s than there were 70s, 60s, or 50s. So that's a stem and leaf. Now we want to organize that data into a frequency distribution table using intervals. So I'm going to have to kind of go back and forth here a little bit. So there's 55, there was 1. 60 to 64 was none. 65 to 69, there were 4. 70 to 74, there's 1. 75 to 79, there's 2. And you can also use, tallies. This was 0, and that was 0. 80 to 84, there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me double check that. 1, 2, 3, 4, 5, 6. And then 85 to 89, there's 3. 90 to 94, 1, 2, 3, 4, 5. And then there was one at 95 to 100. All right, so now to set this up, I'm going to use the edges because otherwise I'm going to run out of room. If I was doing this not on the smartboard, I'd be using a straight edge. So I'm just going to start here and kind of go, and I have to write these on the side. These are the intervals of the grades, and I might have to extend it. So I'm going to do in here 50 to 55 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, and 95 to 100. So these are the intervals of grades from a marking period. And this is going to be the frequency. All right, and so it goes from 0 to 6. So this will be 1, 2, 3, 4, 5, and 6. And then I'm going to use a different color. There's 1 from 55 to 59. So we just go up to that block and over and down and kind of highlight that in. And then there was 4 from 65 to 69. So we let the bars touch. And then 1 from 70 to 74. 75 to 79 was 2. 80 to 84 was 6. 85 to 89 is 3. 90 to 94 was 5. And then we have the one from 95 to 100. And there is your frequency histogram. And that ends this lesson.